I'm Wouter van der Pol. I'm a sales engineer for Avermann Netherlands. Today we are here testing our smallest extruder. We tested a fiber material, organic fibers, coming from the greenhouses. So it's a very fibrous, woody kind of material. It's very difficult to dewater normally. And that's why we choose this material to do a test with. Basically because it gives a good reference point, and you see often if you can dewater this, that you can dewater other things as well. So as you see, it's still a little bit wet. We dewatered it about 48%, which is pretty good for a fresh fiber material. We did the test with a big bag. We filled a big bag. We took 100 kg material. We filled that up in a big bag, and then we took the big bag and feed it into this hopper. The machine will take the material automatically. The ram drives the material forward into the dewatering chamber, which is behind this cover. Here you can see the dewatering chamber. The machine brings the material under pressure. First it starts with 50 bars, it waits a couple of seconds, then it ramps up to a higher pressure, and then a third step to an even higher pressure, and then it pushes through. In here there is a valve, or a kind of closing mechanism actually, that holds the material down. When a pressure is reached, it will open up and will push the material through the chamber. After that, we collected the material in another big bag. We pressed everything through so that complete 100 kg went through the machine and into the other big bag, and we weighed that. And the weight of that big bag was actually 52 kg instead of 100. So that means 45 kg went out in liquid. The liquid is, by the way, collected in here. So there is a collection pan under the machine, and that can drain to another collection tank, or for sewage, or for biogas installations. Today we did the test on organic fibers, but the reason why we choose to test with the fibers is because it's a good reference point. So it's a quite hard material to squeeze out. You have free water, that means that's the water that is on the surface of materials. Can be plastics, can be organics, doesn't matter. Can be packaging material. That's the easy water to squeeze out. That material is not sucked into a fiber structure or in a cellular structure. But if you have water which is in a fiber, in this case it's a pretty woody fiber, that's a little bit more difficult to retrieve. So by testing this material, you get a very good reference point in what you can do with a machine like this. So we can compare that. We can also use it in MSW, so household waste. In household waste you find some woody materials, some spongy materials, textiles for example. They are very similar as this kind of woody structure. So the results we get on this material are very usable in other industries as well. So this machine is capable of squeezing organic waste, depackaging, so PET bottles, things like that, but also MSW, so general waste, which has a lot of water in it because of some reason.